Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is shortest path in binary matrix. So let's go to LeetCode, give this problem a read. Given an n cross n binary matrix called grid, return the length of the shortest clear path in the matrix. What is a clear path? Well, a clear path is a binary in a binary matrix is a path from top left corner, so this corner right here, to the bottom right cell, right over here, and given that we are only visiting zeros and zeros represent a clear path, and you can visit basically these cells 8 directionally, which means you can visit the diagonal values as well. So in this particular case, the first example, if you're trying to go from top left corner to the bottom right corner, there is only one path, that is from 0 diagonally to the bottom right 0. So that will be the answer will be 2, because you came across 2 values which are 0. To reach here, you went through 2 values. All right, so now let's understand this problem through the second example, which is right here. So how many paths do you see from the top left corner? So let's say this is my target, this is my destination, and this is my origin. This is my origin. So how many paths do we see? So one of the path is going like this. Okay, so visiting over here and then this corner and then right over here. But if you see that we are allowed to visit the diagonal values as well. So from here I am allowed to visit this 0 diagonally as well. So if you see, going from this 0 top left to bottom right, in this path I came across, so this is, I'm gonna say, I'm gonna draw these paths again. So one of the path is this is one path, and you came across basically 5 zeros in this. Another path is this, so here and then diagonally and like here. So in this case you came across four clear zeros, or clear path, clear zero. I don't know what they're trying to say, but we're trying to count the number of zeros that you encounter while going over there. So of course this is better, right? This is better because we're trying to minimize the number of zeros we see, and the reason is we're trying to find the shortest path in this binary matrix. So how do you think we will be doing it? Well, first thing first, we will be using binary breadth first search, BFS, and we will first append this value to my queue, right? If this is 0 1 2 0 1 2, so I will be appending that to my queue, so that is 0 0. But remember, I'm only appending this if this value is a 0. If this is not 0, then means you cannot go to the bottom right corner, and you will return basically -1, and we will handle that. But if that is a 0, you basically append that to your queue, and then you start your while loop. And in the while loop, you remember, we have written BFS thousands of time, and then you'll basically exploring these 8 directionally, and wherever you are seeing these zeros, you will be appending that to the queue. Given that on level 1 you will have these levels, and these levels will start at 1 because you are seeing a 0, so you will start that level as 1. But when you keep seeing all these different values, you will keep appending them to your queues, and on one level you will explore the given number of queues, so given number of nodes. So like on level 1 you will explore this particular binary cell, and then on level 2 you will be exploring these 2, by the way, so these 2 at the same time. So that's your next level. But then from here the next level of this would be this, but of this cell the next level would be here. That is why this reaches here before this path, and that is why that's what we return. So it's a simple problem. Honestly, we have done not thousands, I'm just saying it, I'm just making it up, but we have done enough number of problems to write the solution. And I would expect, after solving the previous problem, I would expect you to write this solution yourself. So first thing first, let's get the row and column of this grid. And why not? Let's get the visited set as well. And do we need visit set in this case? It's a BFS, so yes we do. Yes we do. We don't want to explore the visited values. So we'll have grid, then we'll have length grid, although these are going to be same, but you know, it's okay. So now and then we're going to have our queue initially empty. So if let's say this grid at 0, 0, if this exists, then I will append this value basically to my queue. Okay, so, and I should rather say it like this: if r is greater than equals to 0 and c is greater than equals to 0. That's a nicer way of basically checking if the first value exists. And if that value is 0, if grid at 0, 0 is basically, these are the edges we're checking. Okay, if that's equals to, if this value is equals to 0, then we will append that to my queue. So queue dot append. What are we appending? We are appending 0, 0. Now let's start our main algorithm. So because we are seeing a 0, and initially I will have let's say the length of the path, so path length, I should call it path length initially here, because we are already seeing, and you know what, I will just call it I will call it -1. But if you are appending it right here, that means this should become now 1, because you are seeing 1, 0. Now we are finally ready to start our queue. Okay, so while queue has values, then you're gonna empty all those values into your queue. Then let's empty the main queue for let's call it cell this time, cell in queue. Let's get row and column of this cell. Now let's explore all the neighbors 8 directionally, remember. So for dr and dc in this right here. So this is something that basically we'll have to think about. First is basically let's think about, there is a cell and we have to explore all the directions. So first let's explore all the just the 4 directions. So 4 direction would be 1, 0, then it would be -1, 0, then it would be 0, 1, and then it would be -1, 0, -1. All right, now explore the diagonals. So that would be incrementing both, then it would be incrementing 1 but basically decrementing the column, then it would be incrementing decrementing row, decrementing, or I would say decrementing row and decrementing column, and then it would be decrementing row and incrementing column. So these are 4 diagonals, by the way. So this increasing means this corner, and then decreasing means this corner, and then both decreasing means this corner, and row decreasing, and this increasing this corner. The last one, this one was this corner. Well, I'm sure you know this is not the most complicated concept here. I'm sure if you are coding it, like, I'm sure you know. So dr plus r and dc plus c. Now if new r is greater than equals to 0 and new c is greater than equals to 0 and new r is basically smaller than r and new c is smaller than c, big C, don't wanna make this mistake. And if this is the case, then, and one more thing, we are only looking for zeros. So if grid, let's say all these bounds are good now. And one more thing is that we need to basically append this 0, 0 into my visited set. Okay, because I don't want to add that again. So visited dot append, or add, because it's a set, add 0, 0. And if this particular value, so new r and new c is equals to 0, and given we forgot to check that this new r new c not in visited and it's equal to 0. All right, now that makes sense. If that's the case, then this particular grid is we need to explore it again until we reach the last digit. Okay, so here you can say q dot append. By the way, if it's equals to basically the last value is equals to 0, then we will increment our path length and then return that. So but let's just do let's just append that q dot append new r new c and then visited set dot add new r comma new c. All right, so while exploring all this direction, there will be a point where we will have the last column accessible, right? And once you go out of this, by the way, I want to increment this length. Okay, I want to increment this length, and this is what we will be returning in the end. But before we do that, this cell right here is when I need to check if this is equals to this last, basically this bottom right corner. So if this r is equals to big R and C, by the way, these are the length, this is the length. So maybe it would be better that we check, because we are exploring the indexes, so -1, and C is equals to big C -1. All right, I hope you understand this. And if that's the case, then I just want to return path length, right? Path length. And remember, this is the cell that's already in my queue, so I have already incremented that as a value while appending it to my queue. So first time I see that particular corner would be over here, but here is not when I'm returning the answer, although I might check if these are equals there, but then I will have to increment this value. And why increment it twice? Because you will not reach here in just like few steps. For bigger grades, it will take you a couple of steps. So this is a better way. You're getting that cell you check if that cell is the corner, and then you basically return the path length. Okay, so this is how you'll be returning it. And I guess that will be it. Finally, we can zoom out, and this is the first time I'll be running this code, so let's see if I run into any typos or anything. Okay, so I just realized that probably we should handle this path length rather than initializing -1, you know, and we don't want to enter like into the while loop. We should just start it with like 0, and then rather than incrementing it over here, and if we did end up adding this 0, 0, we will be entering this over here, right? Like we will be entering it over here. That's when we can increment it. And because we are at that 0, 0 first cell, and then we increment it right here, and we only increment it on that particular level, and finally we will be returning this path length. So if you are on that level, and that level is basically the end, you know, you check, that's when you return basically 1, and we are incrementing it by 1. Initially we should initialize it with 0. Usually we do it in most of the cases, but I thought that you know, I'm outsmarting but anyway, I think, and rather than returning this right here, although if we have an answer, we will be exiting out in our this while loop right here. Otherwise we will be coming out because we did not find a path, or like, you know, the last cell is not that 0, 0, so we didn't add it to the queue, and then we never found this, so we'll return. So I guess this time it should run, and we can submit it. Yeah, passes the test cases. Awesome. Let's write down the time complexity. So I guess worst case, we end up exploring all the paths, because let's say everything was filled with 0, so we will be exploring with you know, all our BFS, but I know the diagonal will reach the first because that goes through the least amount of values. So in this case, but like worst case, we will be writing it big of n square, and then same goes to the space complexity, and that's because we have this visited set. Okay, all right, so I guess this is it, and see you guys later in the next video.